Analysis of wildfire visualization systems for research and training. Are they up for the challenge of the current state of wildfires? During 2019 and 2020, different regions worldwide were struck by unprecedented wildfires. Reports have discussed increased dynamism in wildfires, with violent changes in temperature and wind direction causing trouble to fire response teams. To address the dangers of wildfires, various interdisciplinary research teams have developed different methods to study them. These efforts aim to produce models that accurately represent wildfire behavior. These systems come with very simplistic and limited 2D representations of their output. Efforts have focused on helping fire response management teams. Different studies have pointed out how current firefighter training drills and methodologies were outdated even before the latest developments in wildfires. Haskins and colleagues discuss how some wildfire events are not addressed in firefighter training drills. Wildfire training in immersive environments has become valuable since immersive technologies became a mainstream technology. They provide a safe and cost-effective way to undertake high-risk training for responders. They provide training flexibility for rare and dangerous scenarios not covered in drills. They usually combine data visualization with gamified tasks for realistic learning. So what is the purpose of this review? There is a clear need to understand more about the new state of wildfires. Wildfire modeling and simulation require visualization tools that ease and enhance result representation. Training systems require technologies that accurately represent a wildfire's behavior. There are two main research questions we want to address with this review. Our first research question is about wildfire visualization systems. We analyze in depth current wildfire visualization systems. We want to know what characteristics are helpful in studying the behavior of wildfires. We also discuss which characteristics prevent them from being valuable in the current context of wildfires. Our second research question is about immersive wildfire training systems. We review immersive systems that help train frontline firefighters. We want to understand how capable current training systems are to prepare ground forces against the current behavior of wildfires. We want to identify characteristics that help build an appropriate system that avoids the shortcomings of previous designs. Our search focuses on studies published after the 1st of January of 2010 for two main reasons. Firstly, immersive systems mature around this date to allow them to be used for multiple purposes. Secondly, wildfire publications around this date start to focus on quantifying and modeling different dynamic wildfire behaviors uncommon in wildfire. Additionally, we included a search for commercial immersive wildfire training products. We followed an analysis like that of Williams, Bell, and colleagues, where they reviewed both academic projects and commercial products to draw improvements that academic projects can learn from industry-led projects. So what are the results on wildfire visualization projects? Visualization systems are divided into three groups based on their complexity. These are two-dimensional, three-dimensional, and immersive visualizations. Two-dimensional visualizations can be further divided into three groups based on their use: wildfire modeling visualization, decision support tools, and fire study. Wildfire simulation modeling visualization aids in studying the outputs of different wildfire modeling systems and algorithms. Usually, they are one plot per variable, like the one in the figure. Decision support tools are used to aid during emergency wildfire events. They provide fast and accurate fire numerical data that can be visualized. These systems use ground sensors, satellite images, or historical data to predict the evolution of an ongoing wildfire. These systems focus on fire spread, areas in danger, and general information that can help fire management offices during a wildfire emergency. Fire study systems are used to study historical or simulated wildfires. They overlap each variable in a map to study their influence over the spread of a fire. So, our key takeaway points from 2D systems are: they are one of the most common visualization types, since most of them come by default with fire modeling systems. Their main limitation is that they comprise different overlap images, each representing a wildfire variable. While helpful in emergency response for a quick depiction of a fire, they are limited when studying a real wildfire. 3D wildfire visualization systems provide a more comprehensive overview of the fire's behavior and relationship with environmental elements. They provide an omnidirectional view that is not bound to a single perspective, and they usually have two main uses: studying wildfires and the development of computer graphics techniques for fire effects. Immersive visualization systems provide a comprehensive overview of the fire by allowing full immersion of users inside a fire event. Users can experience either a one-to-one scale or a scaled version of wildfire data, which allows an improved experience compared to non-immersive experiences. In our research, the only system that entirely takes advantage of immersive visualization is Fire. The system allows users to visualize the fire from a first-person perspective, allowing them to experience the spread of a wildfire as if they were present in the event. The key takeaway points from 3D and immersive systems are the following. Most systems share the data engineer pipelines of processing fire data for their visualization. This is useful because it's a starting point for future visualization systems. The visualization of the spread of the wildfire is a good starting point, but it's not enough to study wildfires. And finally, most systems overlook interaction with their visualization. So now let's focus on immersive wildfire training system. After running our search, we realized we had to reframe our research. We were unable to find academic projects focused on wildfire training. Most projects focus on training for fires inside structures like buildings or airplanes. And the closest work was that by Clifford and colleagues, who focus on personnel on aerial vehicles, not ground personnel. From the academic sources, we reviewed systems that prepare different users to react to a fire event and identified key characteristics useful for building a system focused on wildfires. We also want to highlight any elements that wildfire training systems must avoid. Our search identified 6 main characteristics of the reviewed systems: fire wayfinding, or finding routes inside an emergency event, emergency response scenarios where firefighters had to put out a fire, realistic data sources where fire behavior follows either a historic fire or created using a fire modeling system, involvement of fire practitioners or how practitioners were involved in the design and development of the system, user collaboration where more than one user can interact with the same scenario, and the use of immersive systems. Fire wayfinding and emergency response scenarios are crucial for wildfire management and the survival of firefighters in the field. However, emergency response scenarios mostly focus on events inside closed spaces, like the one in the figure. Future systems should focus on fire control and wayfinding in wildfire situations. These projects use realistic fire data to expose firefighters to scenarios as close to real fire behavior. It is crucial that respondents are exposed to behavior of a wildfire before they're exposed to real fire to gain situational awareness of the behavior of the fire. Overall, there was a low involvement of fire practitioners through the development of the reviewed systems. Only 2 academic projects out of 29 mentioned that fire practitioners were involved in all the project stages. It is crucial that fire practitioners are involved in all stages of the developing of training scenarios for firefighters if we want these systems to be helpful in any way for fire services. Collaboration during fire events is critical for the survival of firefighters during a wildfire event. However, only a few academic projects and half of the industry projects mention collaborative capabilities. Most systems focus on using head-mounted displays, with cave systems being the second most used type of hardware. Some projects even compare cave versus head-mounted display, and reported cave being better for multiple users, while head-mounted display being better for immersion. Some projects try to improve immersion by including fire hoses, fire extinguishers, and other tools with haptic feedback to increase the sense of immersion with the hopes of increasing the learning outcomes. Our takeaways from these are that most training systems recreate outdated training deals and practices that must be updated urgently. Most service systems represent small, enclosed, pre-scripted, and predictable scenarios with repetitive drills. These limitations don't offer any advantage over regular fire training drills. So, to conclude this talk, we believe that the lack of immersive visualization systems is why there aren't many wildfire training systems. Even those that exist are systems focused on wildfire spread and not other characteristics like smoke or wind that could be useful for wildfire training. One of the biggest limitations of visualization and training systems was how information can be lost during data abstraction. Both fire practitioners and brigades could benefit from a realistic representation of the datasets. Users can experience being present in a wildfire event, interact with the data, and use their human senses to acquire unique insights not plausible in 2D and most 3D visualization systems.